Why do environmental factors increase electronic noise? Imagine standing near a busy street and trying to listen to a quiet radio station. The background sounds make it hard to hear the music clearly. That's similar to what happens inside electronic systems when environmental factors cause noise to increase. In electronic circuits, noise is like unwanted static that can distort signals. External influences from the environment can add more of this static, making it tougher for signals to stay clear. One big reason is temperature. When things heat up, the tiny particles inside resistors and semiconductors move more randomly. This random movement creates thermal noise, also called Johnson-Nyquist noise. The hotter the environment, the more energetic the electrons become, and the more noise is generated inside the components. Plus, high temperatures can make semiconductors behave unpredictably, causing even more fluctuations and noise. Humidity and moisture also play a role. When the air is humid, moisture can settle on circuit boards and components. This reduces the resistance of insulation materials and can cause tiny leaks or corrosion. These leaks introduce unpredictable currents and electromagnetic interference, which adds to the noise. Moisture can even cause partial shorts, which are like tiny electrical bridges that disrupt signals and increase noise levels. Electromagnetic interference is another major factor. It comes from nearby electrical devices, power lines, radio transmitters, and even natural phenomena like lightning or solar activity. These electromagnetic fields can couple into circuits through capacitive or inductive means. When this happens, unwanted signals get mixed with the original signals, raising the overall noise floor. This makes it harder for the system to distinguish the real signal from the interference. Mechanical vibrations and sound can also cause noise. Vibrations can change electrical parameters in components like piezoelectric devices or cables. This creates microphonic effects, where mechanical motion turns into electrical noise. Even loud noises around the device can cause tiny movements that generate electrical signals, adding to the noise. External radio frequency signals from natural sources like cosmic noise or man-made sources like radio broadcasts can be picked up by unshielded parts of the circuit. These signals add to the background noise, especially in sensitive analog signal processing systems. Poor grounding and shielding make it easier for external noise to enter the system. If the circuit isn't properly grounded or shielded, unwanted signals can sneak in and raise the noise level. All these environmental factors affect the physical conditions of the components and introduce external interference. This increases the noise floor, which is the baseline level of noise in the system. When the noise floor rises, the quality of the signal degrades, making it harder to process and control accurately. Engineers work to reduce this noise by designing circuits with low-noise components, using shielding and grounding techniques, controlling the environment's temperature and humidity, and applying filters to block specific noise frequencies. They also focus on dissipating heat effectively and isolating sensitive parts from vibrations. In short, environmental factors increase electronic noise because they change physical conditions and bring in external interference. Managing these influences is key to keeping signals clear and systems working reliably.